Good morning, everybody. This is our 415 Development and Growth 1. I don't know which lecture is this, but today we're going to look at Michael Kramer's O-ring theory. So let me share my screen. If I minimize this, so now I'm ready. Yeah, so this is from section 4.5 of your textbook. I already posted a separate reading for this theory. You can also check the paper by Michael Kramer. It's a technical paper, but you can read some non-technical parts. You can read the introduction and conclusion. So here we have a model, a theory, and there's a specific model in that paper. And the idea is this. So in today's world, production requires many tasks. Okay, so many different activities. So there's someone in chat. Okay. There are many tasks, many activities, many different inputs, and these inputs, these activities, these tasks are, in a sense, sometimes at least for at least some production processes, they are strongly complementary to each other. Okay. Technically, we call such production functions supermodular, but that's not very important for us now. The typical example, and this is where the name of the theory originates from. That Challenger space shuttle basically exploded because of the failure of one simple piece, which is called the O-ring. Okay, so if we change the production functions in our growth models to be supermodular, or in simpler terms, if we take production inputs to be strongly complementary, then that will have some consequences. Okay, so let's look at this very simple idea, all right, in very simple terms. So now we're going to look at a version of the theory at the firm level. Okay, so we imagine a single firm. So that firm is obviously one of many different firms that would have similar technologies. We denote the output by Y, as is typical. And we assume that for this firm to produce the good or the service that it sells, there are n different tasks. Okay, and here is the number of tasks, the number of different tasks to be completed, to be achieved for the production to take place. Okay, so you may imagine one is transportation, the other is the organization of raw materials, the other is the organization of workers within the factory, the other is the physical production of the good, the other is packaging, etc., right? So there could be many different tasks. And output here in this version will be depending on the quality of each task. Okay, the quality Q will differ across these tasks. Okay, so your production function, as you see, is multiplicative, right? So there's a production function here, and this production function, when these qualities are multiplicative, then this means these tasks are strongly complementary to each other. Okay, so that's the idea, and Q is always between 0 and 1. When it is 0, obviously, at least for one task, if you look at this carefully, at least for one task, if it is 0, then regardless of the qualities of the other tasks, then your production is 0, right? So that's exactly the idea of the O-ring. If it is equal to 1 in all of the tasks, then your production is equal to 1, right? Because 1 times 1 times 1, 1 to the power of n, so it is just equal to 1, okay? So that's the idea. And Qi for different tasks could have some different meanings, different interpretations. All right. So imagine that for each task you assign a worker. Okay. For transportation you assign a worker. For organization you assign a worker. For raw materials you assign a worker. For packaging you assign a worker. Then these QIs for these different tasks would be, for instance, skill levels of these workers. Okay, or you may imagine these Qs as probabilities. Okay, so each task, imagine now that production process is stochastic, so it is subject to some sort of randomness or some sort of uncertainty. And for each task, there is a probability of failure and probability of success. Now, you may imagine that Q is the success probability. So Qi would be the success probability of task I. Okay? Then you can think of this production function as a stochastic production function. So at the end, the multiplication of all these probabilities will give you the probability of achieving the successful production, right? Or depending on your context, depending on what this firm does, depending on how this firm behaves in markets and behaves within the factory, etc., how this firm is managed, depending on all these elements, you may have different interpretations for these QIs. Okay. The simple example we're going to focus on will have two tasks. All right. Very simple. This is a very simple example. So we have two tasks. There's one firm and two tasks, and this firm will have 4 workers. Okay, 2 of them would be high skilled. 2 of these workers will be high skilled, and 2 of these workers will be low skilled. Okay, and obviously high skilled guys have higher human capital. So imagine that they have advanced degrees, or they have better working capacities. You may again develop different stories about this. And basically we denote the skill level of the high skill guys by H, and the skill level of low skill guys by L. So H is greater than L. Okay, so that's our basic assumption. And since we have 2 tasks, obviously we have this production function. Right now we have 2 tasks. Qi and Qj are the skill levels of the workers that we attach to these tasks. Okay. Now there's one important assumption. So production takes place in cycles. All right. So there are different cycles. So in one production cycles, only 2 workers are working. Okay, because there are 2 tasks, and each task is going to be performed by only 1 worker. So if you have 4 workers, you can have 2 simultaneous production cycles, right? So in one production line, in one production cycle, 2 workers are working. In the other one, 2 workers are working. Both of them, in both cycles, each worker is basically responsible for one of the tasks. okay? Now then there is a very simple allocation problem for the firm, right? So how does the firm allocate workers for these tasks? Okay. Now, let's look at two different allocations. Okay. In the first allocation, we assign high-skilled workers with low-skilled workers. Okay. We match high-skilled workers with low-skilled workers. So what happens? Well, if I match a high-skilled and low-skilled worker together in one production cycle, so production is equal to H times L, right? Because this is QI times QJ. And in the other cycle, I have now two other workers. One is again high quality or high skill. The other is low skilled. And again, production from this match is H times L again. So total production is equal to 2 times HL. Okay. Now in the other allocation, we look at what we call assortative matching. All right. Now I am matching high-skilled workers together with the high-skilled guys and low-skilled workers together with the low-skilled guys. All right. So in one production cycle, in one production line, I have 2 high-skilled guys producing the good, and in the other plant, other production line or other production cycle, I have the low-skilled guys. All right. So the total production is then H squared plus L squared. All right. And of course, H squared plus L squared is greater than 2 times HL. Right? This is a simple mathematical fact, as you see there. So allocation 2, when you use as the firm owner or the firm manager, when you use assortative matching, when you put high skill guys together and low skill guys together and separate them from each other, then you have the highest level of production. Okay, that's the result of strong complementarity. Okay. So more technically, this is called positive assortative matching. Okay, workers with high skills will work together. Workers with low skills will work together. Okay. Now the obvious question is, why this firm level theory? This is about just, you know, skill levels of workers. How this theory be relevant for development and poverty? Okay, we have to think about this question because this is a development class, right? And the idea is, if there's positive assortative matching, then that would increase inequalities. That would deepen the problem of dualities in the economy. All right. Remember, we discussed earlier that there could be dualistic development, right? In some regions or in some sectors, there is signs of modernity, signs of economic development, you know, higher volume of production, more skilled people, etc. And in some other region or in some other sector in the economy, there could be poverty, you know, low productivity, low human capital, and other sorts of underdevelopment problems. So if there is indeed sector level or region level positive assortative matching, then those inequalities and those signs of duality would increase, would be even more stronger, even stronger. Okay, because high skill agents, they already, I mean, even if there is no assortative matching, high skill guys would earn more, right? But then with positive assortative matching, high skilled guys increase their wage, and that would harm the low skilled guys in the economy, right? Because low skilled guys, if they work together only with the other low skilled guys in the economy, they produce only little. So positive assortative matching would have a tendency to increase existing wage inequalities in an economy, and wage inequality matters a lot because it would create higher wealth inequalities and higher consumption inequalities. So inequalities, the types of inequalities that matter would be centrally related with the earnings inequalities, right? And again, there's regional inequalities within an economy. So Turkey, for instance, if you look at Turkey, you would see regional inequalities, right? So there's usually a divide between East and West. Sometimes there's a divide between the coastal side and the central Anatolia. So if you think about where are the, so where the firms are and where the most productive firms, the firms that export relatively high-tech goods are located, then you can see the pattern. Then you can start seeing a particular pattern, and possibly there is assortative matching, all right, in terms of the regional allocation of resources. So when I say allocation of resources, I just don't mean the allocation of workers. The same is true for capital. The same is true for land. The same is true for skills. The same is true for energy, etc. Okay. So another example would be creating the complementarity not between workers, but with the firm and the worker. Okay, now this now becomes more of a macro example. Okay, now we have two firms in the economy and two workers. Okay, so you may imagine we have 200 firms or 2,000 firms and 2 million workers. Doesn't really make a big difference. But the important here, what is important here is that one firm is more productive than the other, okay? And one worker is more skillful than the other, okay? So in that case, what happens? The same mechanism, the same positive assortative matching mechanism will apply, obviously, right? So in this particular example, one of the workers is 3 times more skilled. Okay, so the skill levels are 2x versus 6x. X is some number, right? And firms' productivity levels are equal to A and 7 times A, right? So one firm is 7 times more productive than the other firm, right? So now we can look at different allocations, right? So in the case of positive assortative matching, what happens? One firm, the low productivity firm, will be hiring the low skill guy. So production is equal to what? 2AX, right? The production is equal to A times 2X. A is the productivity of the low productivity firm, and 2X is the skill level of low skill guy. So 2 times AX is the total production in this low productivity, low skill match. And in the other match, with high productivity firm matched with the high skill guy, the production is equal to 42AX. Okay, so total output then is 44 times A times X. Okay, and if you compare this with the other allocation, okay, if you calculate the other allocation, you would have 14 AX from one match and 6 AX from the other match, right? High skill guy matched with the low productivity firm plus low skill guy matched with high productivity firm. That would give you 20 times AX, and the positive assortative matching allocation would give you 44 times AX. Okay, so if these firms are profit maximizing, you know, the cost structure would be the same, then they would follow the, so they would maximize their profits when they maximize their outputs. So then they would exercise positive assortative matching. Okay. So that's the simple idea, of course, but then you may imagine extending such simple examples with many different inputs, with many different regions, many different firms. Some firms are innovative, some firms are not innovative, some firms are very high, you know, highly productive, some firms are not very productive in different sectors and in different regions, right? And then you have the workers with different education levels, but also with different hidden abilities. All right, some abilities are only discovered when the workers when they start working within a particular firm, and some of the time, if you think about more realistically, in the real world, some skills are sector specific, okay, and task specific. So I may have a, you know, PhD degree, but if I work in a transportation sector, possibly I have low productivity. If I work in the management sector, the management part or the management task, possibly I have higher productivity. All right, and if this firm has a research division, possibly my productivity is highest when I work in the research section. Okay, so there are many different ways that you may imagine this positive assortative matching would apply. So if you write a very realistic, a highly complex model of an economy with different regions, different sectors, different types of firms, different types of workers, then you can play with this idea to create, to understand regional inequalities, sectoral inequalities, inequalities between workers of different ages and different education levels, right? Because age is an important matter. Your productivity as a worker, given your education, would have some particular patterns depending on your age. If you look at the, for instance, age earning profile, so if you put on the horizontal axis the age of the worker, and if you put on the vertical axis the earnings, there is usually a U-shaped pattern. Okay, so first you earn a little, then towards middle ages you earn a lot, so then there's this plateau of high earnings, and then you know, when you are closer to retirement, you earn relatively little. Okay, so age could matter as well, education matters, and experience also matters. All right, so you could be a young worker with very high skills, you know, new skills, but then the experienced workers could be more productive initially. Then you start accumulating your experience within the firm, and then your higher education or more important skills would dominate, and you earn a lot compared to your boss or manager 10 years later. Okay, so in general, these examples are very simple, but there could be more realistic stories that still build on this notion of positive assortative matching, because that's our assumption. I mean, the fundamental assumption is strong complementarity. Under strong complementarity, we have positive assortative matching. we can have another example. Now, again, there are two tasks, okay? But now, one of these tasks could also be performed by a robot, okay? So this task, this one, task one, is always performed by a human worker, H, okay? But the other task can be performed by a human worker or a robot worker, okay? And productivity of the robot worker, here as you see, it's beta relative to the human worker, is greater than 1. So a robot worker would be more productive than a human worker in this task, okay? Now the question is interesting because if we can write the profit, what do I have? I have the price of the product. I have the output, right? Output depends on H. I have two workers now. One is performing the task 1. The other is working for task 2, but also we have the robot worker. So the total wage cost is W times 2H because I have two workers and I pay a wage, W, and then we have the price for the robot, PR. Okay? So the question is, of course, is there a solution? Right? Now you can try to solve this problem. Of course, you're gonna take prices as given, and at different prices, you're gonna find different solutions. Okay, maybe there could be a better notation. So you could do like this. So make this H1 and H2, okay, because these are two different workers now. So H1 here is performing the first task. H2 is possibly employed, you know, depending on the prices and productivities. So H1 is here, H2 is here, and then you have W times H1 plus H2 as the total wage cost. Okay, then you can tell me, this is a very simple mathematical problem, but you can tell me something about when is the robot worker employed, under what conditions does the firm employ the robot worker? Okay, so think about this problem. Next week we can talk about the solution. Your intuition suggests PR is important, right? If PR is low enough relative to something, then you would hire the robot worker. Okay. So that's all for the O-ring theory. You should read the text, obviously, your textbook, but also read this Financial Times article. If it is I don't remember which one was at the Financial Times, but there's a nice paper that by Tim Hartford. And then next week we're going to continue with the growth diagnostics approach. I already posted some material. And now I can answer your questions. I can respond to your comments. Hello. You're welcome, Özgür Emek. All right then. Okay, so this is an influential theory. Try to understand this idea of strong complementarity, and then see the result by yourself, by working through the math. Okay, why positive assortative matching is profit maximizing or cost minimizing, why it would be preferred under strong complementarity. Then think about that. That's the most important part. Think about how this theory could be applied to development problems that you see in today's world. Okay, think about Turkey, think about Uganda, think about other underdeveloped countries with different sectors, different types of workers, different types of firms. Okay, think about such things, because those are relevant for your overall understanding of underdevelopment. Okay, so the mechanism is simple, but don't forget it could be extended with more complicated stuff, more complicated production functions. As I showed you in the last example, we could introduce robot workers and different types of substitutability relationships, right? Because in the last example, if you were careful enough, you would see that a robot worker and a human worker are substitutes for the second task, right? So there could be different types of strong complementarities between the tasks, but substitutabilities within the task. Okay, so you should be paying attention to such extensions. All right then. I will see you next week, Monday morning, 9 a.m. Until then, take good care of yourselves and stay focused. All right.
Teşekkürler hocam.
Görüşürüz hocam. İyi günler.
Rica ederim. Görüşürüz.
İyi günler hocam.